Assalamualaikum. My name is NUR'AIN and I am from School of Electrical Engineering, College of Engineering, University Technology Mara, UITM Shah Alam. I will make a presentation for our research paper entitled Performance Analysis of Radio Propagation Models in Vanet Application. This is the outline for my presentation. It will start with an introduction and ends with the conclusion. In between, there are problem statement, objectives, scope of project, methodology, and results and discussion. For the introduction, Vanet or Vehicular Ad Hoc Network has been implementing the principle of Mobile Ad Hoc Network or MANET, a method of spontaneous development of mobile wireless network devices that can change locations and customize themselves through wireless network. As you can see from figure 1, it shows a Vanet developed for the communication between vehicle to vehicle and vehicle to infrastructure in purpose of for safety, navigation, and other roadside services. Figure 1 shows the scenario of how Vanet works on the road traffic. Next, a radio propagation model or RPM is typically built to predict propagation behavior under similar constraints for all connections. In Vanet, RPM is used in many operational environments to estimate path loss, and modern road infrastructures such as flyovers, underpasses, and road tunnels are the working environment. For instance, in order to predict the behavior of propagation, different RPMs must be created for different environments. For the problem statement, Vanet has been regarded as a promising technique that can help tracking and enhancing the safety and efficiency of traffic on the road technology between vehicles. And in Vanet, the main concern is the obstacles for the communication between vehicles and roadside unit or RSU, such as the buildings along the road. Hence, the concept of RPM is used as one of the main factors for the communication in Vanet. However, there are various types of RPMs which contain different algorithms for each and resulting to different results and uses for each RPM. Thus, this project aims to evaluate the best performance of different type of RPM at a selected traffic area by using a simulation-based study. For the objectives, we have three. The first one is we want to perform the simulation of Vanet in the real-time traffic on Network Simulator 2 or NS2. For the second objectives, we want to analyze the different performance of different type of RPM that characterize the vehicular environment by analyzing the delay, packet loss, and throughput based on the simulation on real-time traffic. And then for the third objective, we want to determine the best RPM for Jalan Besar Selayang Baru, Batu Cape, Selangor. For the scope of project, only 3 RPMs were chosen for the evaluation of their performance in Vanet, which are free space model, two-ray ground model, and Nakagami model. The earliest radio propagation model, which was used in Vanet, is free space radio propagation. Next, two-ray ground is also one of the RPM used for protocols performance in Vanet, and this model is said to be the ideal model to be used in most Vanet study. This is because when considering a ground-reflected propagation path between transmitter and receiver, it is said that two-ray ground is more practical compared to the free space model. In terms of Nakagami, it was found by the existing research saying that this model has more configurable parameters. Next, we move to the methodology. In terms of the map, the analysis study of the radio propagation model or RPM performance is done by performing a simulation of real-time environment based on the real traffic at Jalan Besar Selayang Baru, Batu Caves, Selangor. Next, in terms of the parameters of simulation analysis, the simulation and analysis of 3 RPMs performances has been conducted with few parameters for observation as shown here. Basically, the simulations are conducted for 6 times according to different number of vehicles for each type of RPM, which are 50, 60, 70, 80, 90 and 100 vehicles. And the traffic modeling, we use CBR. And in terms of the routing protocol, we are using ad hoc on-demand distance vector routing. It is one type of routing protocol used in mobile ad hoc network related reactive routing protocol, which establishes a path to the destination by transmitting route request packets across the entire network. For the radio range, we are using DSRC or dedicated short range communication. And in terms of the MAC layer, we are using IEEE 802.11p. While for the speed of vehicles, we set them at a random. Next, for the simulation software, the main operating system used here was Linux Ubuntu 20.04. It has been installed as a dual boot system on laptop. Next, the simulation tool used is Network Simulator 2 or NS2. It is used along with Java OpenStreetMap or JOSM. We also use Mobility Model Generator for Vanet, known as MOVE. And last but not least, we use simulator of urban mobility known as SUMO. For the flowchart, after Ubuntu was installed, the simulation process was started with JOSM. The desired target location must be determined and downloaded by using JOSM. Then the file was converted to .xml file in order to be used in SUMO. Next, in Move, the file created from SUMO has been transported to simulate the movement of vehicles based on real time. NS2 as the final simulation process is used to obtain necessary data. Now let's watch a bit of video footage that is related to the simulation using NS2. For the result and discussion, the experimental analysis is the evaluation in the impact of the RPM in form of graph representations. Few parameters have been taken to measure the relationship of variables that could affect the performances of RPM in Vanet, such as throughput, end-to-end delay, and packet loss. First, for the average throughput, free space model has the highest throughput result with a total average of 306.97 kilobit per second, while two-ray ground model was at the second place with only 0.73 kilobit per second in difference. With this, two-ray ground was still considered having one of the best performance of throughput on Vanet. In terms of the Nakagami, it recorded the least performance at Jalan Besar Selayang Baru with only 267.52 kilobit per second of total average value. Next, for the end-to-end delay, free space model recorded the lowest delay time for node communication with a total average value of 6.86 milliseconds. However, due to the high delay between communication with corresponding nodes, two-ray ground model performs the worst delay characteristics with a cumulative average delay of 34.10 milliseconds. This could probably happen because free space ignores more obstacles on the road compared to the other RPMs. And last but not least, in terms of the packet loss, it can be concluded that free space model has the best performance as it has the same rate of packet loss for communication between every amount of vehicles, which all is lower than 1%, making it perform better with cumulative range at only 0.19% for the whole data. On the other hand, Nakagami has the poor performance as it scored the highest value of total average packet loss at 1.97%. Here we can conclude that Nakagami are considering many factors of obstacles on the road. For the conclusion, it can be concluded that free space model has the best performance of RPM in terms of simulation. This is because free space model performs a better performance for the communication between vehicles and roadside units as it has the lowest value of the end-to-end delay and packet loss. Plus, free space model also recorded the highest throughput because it ignores more obstacles on the road. Due to the greatest amount of delay and loss of packet loss with corresponding nodes, Nakagami model was found to have the poor performance. This is because Nakagami are considering many factors of obstacles on the road, so that is why in the simulation Nakagami seems to perform the worst. However, one must know that the performance of radio propagation model for different type or condition of traffic could be vary. I think that's all. Thank you for making time to sit through this presentation.